Okay, today's Tuesday, October 23rd, and we're doing Eureka Lesson 2.11, Module 2, Lesson 11. And your learning goal today is we are going to use the standard algorithm to multiply decimals, and we're going to do it by first changing the problem, but then if you change something, you have to undo the change. Okay, so we're going to really talk about changing and then undoing, okay, and you'll see what I mean by that soon. Today I want to start by talking about how we can change a number to get rid of a decimal point. You know, if I have a number like 146 and 82 hundredths, can I just say, you know what? I want to make that a whole number. I'm just going to get rid of this decimal point. Can we do that? No. What's one way we've learned that you can get rid of the decimal point? Niv?
You can write the first digit as value.
Oh, you mean we can write it in unit form?
Yeah.
So we know that this is 14,682 what's? Hundredths. Yeah, so one way we can quote unquote get rid of the decimal point is by writing it in unit form. Another way we could do it is by multiplying, can't we? If I take this decimal point and I want to move it to here, what am I doing? Multiplying by 10. Would that get rid of the decimal point? No. But if I move it here and then multiply it by 10 again, would that be getting rid of the decimal point? So if I multiply 146 and 82 thousandths by 100, I would get 14,682. Does that get rid of the decimal point? That's changing the number though, isn't it? When we do unit form, is this changing the value? No. If I multiply by 100, am I changing the value? I am changing it, huh? Okay. Try this next number, 36.9. Writing it in unit form is not going to change the value. How can I actually change the value to get rid of that decimal point? Write it down in your notebook. If I multiply 36.9 by 10, how does that shift the digits? The digits all shift to the left, which basically means the decimal point is moving to the right? So then the number will be 369. Did I change the value? Is the value of 369 different than 36.9? Yes. Is it bigger or smaller? How many times bigger? But it got rid of the decimal point, didn't it? Yeah. Okay. What about this last one? 458.912. What do I have to multiply by? 10, 100, what? 1,000. If I multiply that by 1,000, I will change the value of the number, but I will also only have a whole number. Does that make sense? Okay. We're going to do 7 and 38 hundredths times 41. Of course, we know the first thing we need to do is to estimate. Estimating helps us find about how big our answer should be. So 7.38 is pretty close to what number? Okay, 41 is pretty close to what number? 40. 7 times 40 is 280. So our answer, our final product, should be pretty close to 280. Okay, now let's actually solve this problem. We have 7.38 times 41 over here, right? But we think to ourselves, how can we temporarily change this problem? Now, keyword there being temporarily. We can't change the problem on the math test, but can we change it temporarily to make it easier? Okay, let's temporarily change this problem so that there's only whole numbers. Well, if I multiply 7.38 times 100, don't I get 738? So I'm going to temporarily change this problem by doing 738 times 41. That's a lot easier because there's only whole numbers. Do you agree? Okay. So when I multiplied 738 by 41, I got the final product of 30,258. Is that close to our estimate of 280? No. No, right off the bat, that should tell you that's not right. Why is that not right? I did all correct math. Did I do my original problem of 7.38 times 41? No, I changed the problem by multiplying one of the numbers by 100. I made it 100 times bigger. So next to this problem, I want you to write the word, get in this habit, write change. What did we do to change this problem? We multiplied one of the numbers by 100. So then since we changed the problem, what do we need to do to undo the change? If I multiply by 100, how do I undo that? Over here, I want you to write next to the answer, I want you to write undo. What do we need to do to undo it? Well, we have to divide it by 100. So I have to take my final answer 30,258, and I have to divide it by 100. When I divide something by 100, what happens to the digits? Do they shift to the right or to the left? Okay, so originally, my decimal point is here. If they all shift to the right one time, the decimal point will be here, right? But how many times do I have to shift it to the right? So my final decimal point should be right here. Does that make sense? When you undo, because we changed it by multiplying by 10, we have to undo the change by dividing by 10, which means my decimal point needs to be right there. Now my answer is 302 and 58 hundredths. Is that closer to 280? Yes, so I feel good that this is my final product. Again, we're changing temporarily the problem, and I always want to see you write down the word change and how you're changing it, and write down the word undo and how you're going to undo the change. If we know that 36 times 134 is 4,824, then 36 times 1.34 will equal what? Well, when you do this kind of problem, let's analyze it. Is the first factor the same?
Yes.
Okay. What about the second factor? How does 1.34 compare to 134? How does it compare? Akil?
It's the same except 1.34 has a decimal in between the
Okay, but what's the value difference?
the hundredths place.
Huh?
So like
Which number is bigger, 134 or 1.34?
130.
How many times bigger is it?
100.
So to get from this number to this number, what did they do?
They divided by 100.
They divided by 100. So what does that mean for the product? This product, is it going to be bigger or smaller than the second product? Is this product going to be bigger or smaller than this product? Bigger. How do I get from, if I had to divide by 100 to get from here to here, how do I get from here to here? What do I need to do? Everyone? Okay. So what will 36 times 1.34 equal? 48.24. Very nice.